Okay, so yes, we'll start to talk about the knowledge graph. And just before I really deep into the knowledge graph, I still want to recap a little bit what we talk about examples of supervised, unsupervised, some basics before we move on to the knowledge graph. So this is the graph we just talked about a couple of minutes ago, and also I discussed the graph in the videos in earlier sessions. So basically, the difference between the knowledge graph and the traditional machine learning is traditional machine learning, we tend to generalize insights from past data. So it has a limitation on the sample size of the training data. But the knowledge graph can actually have the induction. So basically, there's a logic function in the knowledge graph. We can actually learning some related sample to understand a smaller sample. So in this case, what we can show here is what I told you guys is for traditional machine learning, we just mimic doctor's decision on which one is positive, which one is negative on the COVID-19. But going to the knowledge graph example, what we can learn is beyond what doctors know. So we are not simply mimicking doctor's decision on identifying positive or negative. We are kind of assembling doctor's decision on different components, and we can generate some new knowledge the doctor do not even understand, do not even know from his past decisions. So this is a big difference between the knowledge graph and the machine learning, which is machine learning based on learning from the past data. But the knowledge graph will generate some knowledge the doctor didn't even know before. So it's not from the doctor's past decisions. So we also talk about the supervised learning in the videos. I'm not going to spend too much time on this. And also the graph just show you guys how exactly we combine big data with our research. We can use the machine learning to analyze a large volume of pictures or textual data. And also we talk about several applications. And again, it's very detailed discussed in the videos. I'm going to skip rows. So one thing I do want to emphasize here is what exactly, like we talk about so many researches, sometimes research on this, research on that. Sometimes you will think like we're doing like things differently, spread out, there's no focus. Yeah, I just want you guys to point out the focus before we move on to technical stuff, before we move on to the knowledge graph, before we move on all these different things. The focus of this lecture and the FinTech is we're using the technology to help two groups of people. One is we help using technology to help investors, and we use the technology to help managers, the executives of corporates. So this is the focus I think all of us need to keep in mind, because like I said, when people heard like big data, machine learning, it sounds very intangible, something remote. But actually it's not. It's very focused for us, for business, for finance, and for information system. What we need is how can we apply the technology to help investors, and how can we help apply the technology to help managers. In our today's case, we're talking about a knowledge graph. How we use the knowledge graph to help investors, how we use knowledge graph to help managers. So we're kind of doing the different things from computer science major, because they are the scholars who create the algorithm of knowledge graph. We are the group of people who are applying the knowledge graph to investor decision making and the manager's decision making. So I always want you guys to keep the big picture, because sometimes too much details, too much techniques, just forget about your profession. You forget about where you are. No matter how difficult technology is, no matter how much big data, how complicated it is, just remember to the very higher level, what we are doing is we're trying to use these techniques, the technology to help investors, to help managers. That's the purpose of FinTech. That's the purpose we have to keep in mind. And in the earlier videos, we also talk about what data we actually have. I'm going to skip this because once you have the knowledge graph and the machine learning, you can handle this data in a very efficient and informative way. Again, the only difference between the knowledge graph and the machine learning is machine learning can understand some past data to generate, to make a predictions based on the past activities. But knowledge graph can connect the different data together. So like I said, for financial crisis, if you use machine learning, you have to learn the patterns of the financial crisis from the past financial crisis. But if you have knowledge graph, what you can do is you can use related events to understand the insights that related to financial crisis. So that's the example we mentioned, which we will talk more. These all the slide you are seeing here, you can just refer to the videos, including this one. So we talk about like what's supervised, what's unsupervised, what's self-supervised, what transfer learnings, what's ensemble learnings. I also talk about reinforced learnings, adversarial learnings. So knowledge graph is the one we are going to focus on today. Like I emphasized at the beginning of the class, this is helpful if you just read those videos and then listen to today's class, and you will see what is going on and what is exactly the knowledge graph, and you need these basics like this from the previous literatures. So I do want to highlight this the slide, which is you can see what is going on is we compile different models. So we have the CNN, we have the neural network, we have logistic regressions, we have a gradient boosting, we have different models. So how to exactly, if I add a knowledge graph here, knowledge graph is not here, but I can now add a knowledge graph here. So one question I want you guys to ask yourself, and you should answer, you should have the answer for is, how exactly select a model? Like we have so many machine learning models here. We have so many benchmark here. So so how exactly we select the models for this? So this is like normally we look at accuracy and F1 scores. So we want the one which has the highest accuracy and also highest F1 score. So in order to select the models. So this is the stuff also covered in the previous video, but I do want to highlight here because I didn't put a knowledge graph here, but you can add a knowledge graph here to see if knowledge graph is better than other models, then that's the one you choose. If it's not, try something else. That's about the model selection. So I just simple summary, the model selection is important, and we're talking about knowledge graph. I'm not talking about knowledge graph is the best one, but you need to know whether, when, and how, and in what case knowledge graph can be the best model you should choose. So another question you guys keep asking me, why machine can learn something better than human? Why machine can actually figure out a pattern, but human cannot figure out? So you can see that this is the pattern. This is the pattern, like what does this figure mean is, so this is the learning time. This is the iteration. Each iteration machine is trying to make a prediction, trying to understand the data. So 2,000 times, what does that mean? Means the machine trying to dig into the data for 2,000 times, and the performance is about 67%. So what does that mean? So I can give you guys a metaphor. What does this mean? Let's say if you want to take you want to take an exam by human. So after you take each exam, it's like iteration. So this one is like you are taking 2,000 exams. And this is what's the performance after you take the 2,000 exams. So machine can do this maybe in 3 days, but human can do the 2,000 exams maybe have between 3 years. So this is the computing power kind of liberalized the power of the machine. So what we can see here is the machine can keep doing the data, one by one, and until the 2000 times, we can hit the accuracy of the 67%. So one thing I point out is human have to do this for a long period of time, but machine can do it quickly. So how exactly machine can learn from the repeating the practice? How machine can do that? So that's the parameter tuning we discussed in an earlier video too. In the knowledge graph, we also have a lot of parameters. We also have a lot of parameters. So it's more complicated than traditional neural network model. So what that means, for each time when a machine trying to do the practice the exam once time, the machine trying to figure out a pattern and trying to figure out a pattern, and the bottom net, the ceiling is about 26% for the model to achieve. So here we very briefly talk about what we covered in the previous videos. I do want to spend some time on the knowledge graph and how exactly the knowledge graph can help us. So let's talk about the pros and the cons of the knowledge graph. So the pros, it's explicit right now. So like I said, traditional machine learning, you have to learn from the past data, training data, and then you generate something from the past data. But knowledge graph can actually identify related data, related sample, and generate insights from the related sample to understand the focal sample. So that's the beauty. That's the beauty of knowledge graph. I will use one example to explain what is going on. So this is the big difference between the knowledge graph and traditional machine learning. So knowledge graph is one type of machine learning. So I keep saying traditional machine learning. So this is one thing I want to talk about. And another thing is what's the downside of knowledge graph? So if knowledge graph is great, like you can generate a new knowledge, you can have the induction function. Why everybody use knowledge graph? Why now we still have the TensorFlow neural network? The downside of knowledge graph is you have to build the graph. You have to build the connection between the parties. You have to build the relatedness. So that's the difficulty. That's a lot of work. That's a lot of effort to make. So we'll talk about that. So just keep in mind, the knowledge graph, it's not free to use. It has a great advantage because it has a logic and an induction function. But at the same time, it takes time to build the knowledge network. That part is that cost is huge. We will talk about the details. So why exactly when we're talking about the building a knowledge graph, why the cost is huge. So let's look at several examples. I mentioned some of you guys the examples earlier using my own case. We can do this again just to make sure you guys understand what exactly knowledge graph is about. So let's say I'm a movie. I want to watch a movie. Okay. I'm sure you guys use the Netflix. So in the Netflix, they recommend a movie to you. Sometimes so there's two ways to do so. The one way is I watch the past movies. I watched some action movie, romantic movies, comedies. I watched the past movies. So by analyzing my past movies, the Netflix can recommend something I may like. That's one way machine learning do. Logistic neural network can all do that. So that's one thing. Just using my past watching history, I can actually understand, the machine learning can understand what we'll watch next. So this is one traditional way to do it. So what would knowledge graph do is, so let's say I never watched any movie in my whole life. Yeah, I'm a newbie. So in that case, how would you recommend me? I never watched any movie, never. So without any past history of movie watching history, so how would Netflix recommend a movie to me? So here, the Netflix will come in handy. That's the way to go. That's the way to go. So the logic here is, like I explained to you guys, is the logic is the Netflix has to find someone who has the same similar movie taste like me. And the person rated high movies will be the recommendation for me. Does it make sense? That's the beauty of the knowledge graph. Even I have no past history about watching movies, but by identifying someone who is similar taste, has shared a similar taste, movie taste with me, I can get some recommendation. Even I never watched any movies. So, and the key here is, how do I know the person have the similar taste with me? That's the key part. That's the key part of knowledge graph. So you have to build a network. The network is, I'm the one of the node in the network, and you are the second, and then the third one. The nodes are connected to each other. I will show you guys later on the example. So the node will connect with each other, and each node has a relation. So for example, I'm a node on the network. There's another person. His preference is opposite from me. So the relation to me is negative. There's another person. His preference is very similar to me. So our relationship is positive. So you can represent the whole network. You can represent the whole network. You can represent the whole network in a different relationship. So I have a relationship with someone positive. I may have some relationship with someone negative. So, but understanding the relationship between the different parties, what I like the application is, I can learn something. I can watch some movies I never heard before. So it's different from the like a traditional supervised machine learning. Supervised machine learning is to mimic human intelligence. But here, I don't have any intelligence on movies. I have zero intelligence on movies. But by learning the related parties, it kind of can recommend some new intelligence to me I don't even know before. So this is knowledge graph. This is the same thing. Same example I gave you guys is buying clothes, right? Like I'm barely buy clothes. I mean, I'm not a frequent shopper on clothes. So so you learn nothing from my buying history of the clothes just based on my data. But by using someone who is either opposite to me or is positive to me, I can from their collections I can learn something I don't even know before. I can learn some brand I don't even know before. So this is the something beauty of the knowledge graph, and they can generate some new insights I don't even get from my past history. So this is the that's why we need the knowledge graph. And the cost is, you need to build a network. You have to identify who is positive to me, who is negative to me. You have to build a whole network for everyone in a Netflix or in a society. I will give you guys examples. What do I mean by the whole database? Okay, so basically that's the idea of the knowledge graph. And and what we have is what we have is what we have here is you can generate something that is completely new based on my past history. And the cost is, you have to build the network. You have to build a network in order to understand the new knowledge. So let's see one example here. Let's see one example here. So you see, this is a sentence. How do you convert this sentence into a knowledge graph? And this is a picture. How do you convert this picture to a knowledge graph? So let's take a look at the example carefully. So we have a human here. So this is why we represent that, this is a human here. This is a horse, right? This is horse, and we have a horse here. And we have this is a bucket. This is a bucket, and this is glasses. Right? This is glasses. So what do we have here? These glasses here. These human glasses. Okay. So how we exactly represent this network? So you have identity man, you have a horse, you have a bucket, you have glasses. So you can see that the relationship between them, the relationship here is wearing, right? The man wearing the glasses. So the relationship is wearing the relationship. So man and horse, what's the relationship? Feeding. So what we learn from here is man and horse has a feeding relationship. And then and also the horse, what horse is eating from the bucket, and the man, what's the man on bucket, what's the relationship with the holding, is the bucket, man holds the bucket. So this is, so I give you guys an earlier example about movie. So that's a simple example. So basically, if I didn't watch any movie before, you can find someone who is similar to me, or you can find someone who is completely different to me, and you can help me to recommend the movies I'm going to watch. And by understand this knowledge, like this kind of graph, you can also have the similar patterns. You can also have similar patterns. So for example, if you want to predict what the man needs, what the man needs, you actually, if you understand the horse, you actually will help you understand the man's needs based on the horse. So because they have the relationship with feeding, they have a relationship with feeding. So you may predict the man may need buy some bucket, because the man need a bucket to feed the horse. So if you understand the relation between the man and the horse is feeding, and use the horse data, you can help to predict the man's future action. So if the horse is sick, and that data can help you understand what the man need, because you know man has the feeding relation with horse, and if horse is sick, and you will naturally have the reasoning that the man may need to do something to help the sick horse. So this is the graph. Like I said, if you just study the man's activities, you may never figure out how exactly what the man needs. But if you understand the relationship between the man and the horses, and then something happened to horse, you can use the relation between the man and horse as a feeding relationship. You can predict what the man needs. So this is the just extension of the example I gave you guys. The example I give you guys is straightforward: a movie and my friend's movie, and a different person's movie. Here, it's the relation it's more complicated. It's not a positive and negative relation. It has a feeding relation. It has a varying relation. It has eating from relation. It has holding relation. So by building this knowledge network, what you have to see is the connection between the man and the horse. And so in that sense, understanding horse data, you will help you understand the man. So that's the idea of knowledge graph. So let's look at this another sentence. The Einstein was a German-born theoretical physicist who developed the theory of relativity. So you can see the sentence here, the breakdown to the knowledge graph. We have Einstein, we have who occupation is physicist, and we have the relativity theory. We have a physician. This is we have German. So we have all a relationship. So the idea is the same. If you can understand the data from the German, you can help you understand Einstein. If you understand the theory of the relativity, you can help you understand Einstein. So basically, the idea here is we are not just using Einstein's past history to understand Einstein. We can understand Einstein's related parties data and then come back for us to understand Einstein. Same like example I quoted here. If you understand the horse, you can help you understand the man. You can understand if you understand the relativity, you can help you understand Einstein. It's like a movie I give you guys. If you understand my friend's watching habit, you can help me understand my future movie preference. So that's the idea of the knowledge graph. So the difficulty thing here is how we build this, how we are going to build this knowledge graph. So you need to build them in order to use them to generate new knowledge. So why is new knowledge here? Again, so what the new knowledge here is, if you just use the man's past activity, whatever generated will be non-new knowledge. But if you understand the horse, and use the horse data, you can generate some new knowledge to the man. The man didn't realize what they needed before. So the financial crisis is also another example I was talking about. If you understand some related events of a financial crisis, you can generate new knowledge we can never learn from the financial crisis. So these are other examples of the knowledge graph. And we'll talk more about how exactly we can build the system, how we can build the network. Yeah. So so this is the building process. So I still want to talk about some other advantage about the knowledge graph. Some advantages the machine learning. One big problem in machine learning, you guys can see here. So when we use machine learning, we learn from the doctor's judgment on which one is positive, which one is negative. So I told you guys why machine can do such a good job in short term to mimic doctor's decision, because we have a large sample. We have so many affected contingent cases. So because of the large sample, we can easily mimic the doctor's judgment on positive and negative cases. But what if the sample is very small? What if the training sample is small, like financial crisis? We only have like about less than 10 crises in the history. How can we learn something from the sample that is less than 10? So a knowledge graph can help with that issue. You don't have to learn the financial crisis. You don't have to actually learn financial crisis from financial crisis sample. You can use, like I said, some related events for you to understand what is going on with financial crisis. So this one resolve a big issue in machine learning, which is the zero-shot learning, the limitation of a training sample. That's a huge problem in the machine learning, which we can use knowledge graph to overcome it. So this is one advantage of a knowledge graph. So another important thing about knowledge graph is can the technology explainable? So look at these examples. Look at the examples. So you can see that the input of the example is the pixels. The pixels of graph is the input. What's the output is the car, person, animal. And this is more of a black box. So basically what I told you is there's a neural network here. There's a function here. What you do is you input the pixels of the picture. The output is the neural network can help you identify this is a car, this is a person, this is an animal. But what is actually inside the box? What's the mechanism? How exactly the black box dissected the information that normally we talk about dimension reduction is we take out the noisy information, we make the useful information stay in the model. So how exactly we do dimension reduction? How we kind of filter out those noisy information and keep those useful information? How did we do that? So traditional neural network and the machine learning is very difficult to interpret the neurals. You can see more of the video on the explanation of the neural network. But the problem is we don't have a very clear explanation how exactly the model identify car, person, animal. Besides we can explain. The model tried 2,000 times, and then eventually they got the best performance. This sometimes you heard from you heard from people that machine can do the high performance computation and it can figure out the pattern. But what we can explain is they tried many times this high performance computing. But what exactly tried? What's the pattern? What's the pattern actually they get from this? So the black box issue is a big problem in the machine learning. But with the knowledge graph, it's easier because, like I said, it has more reasoning. Because you understand the host data, it helps you understand the man's future needs, new desire. So that's a very logic for you to understand. So for example, for me, the movie, I had never watched any movie before. By looking at my friend's movie, I can get some movie I may like. So the interpretation is relatively easy, relatively using the knowledge graph. So it helps the two big issues in the machine learning area. So that's something you guys can keep in mind. Why sometimes we want to keep an emphasis on the knowledge graph. So so how exactly we do the knowledge graph thing. So let's look at some examples. Maybe this is small. Let me just use this. So some commercial companies they already building a knowledge graph for you already. You can use. So for example, the Wikipedia. I'm sure everyone is familiar with Wikipedia. So what Wikipedia do is they build a two knowledge graph, which is Wikidata and the DBpedia. So what they have is the knowledge, they structure knowledge like a network I was talking about here. So they structure knowledge like here. So basically they have the well-established knowledge structure for you. So what you need to do is to understand this structure, using the structure to make a new knowledge from the relation between different nodes, That's the Wikidata. Wikidata is based on the Wikipedia. Using the Wikipedia knowledge, you build a knowledge network. So we can using one knowledge to understand another knowledge. Like I could earlier go back in my case, I use my friend's movie preference to understand my movie preference. So this is existence knowledge network you can actually use. So I'm sure everyone use Google. I use Google. So Google has a Google knowledge graph. It's also important, so it's called a Google search engine results page. And so knowledge Google knowledge graph, it's represented by the knowledge search engine result page. And so let's see. This is from like Freebase, Wikipedia, CIA. Let's see the big picture. That's what is going on here. Let me see. So you can see that. So you can see the picture here. So I give you guys an example. Okay, I give you guys an example. So if I search heart disease, okay, heart disease. If you search on Google, so this is the screenshot I got from Google. If you search heart disease, you will have some knowledge represented for you. For example, high blood pressure. Cardiac arrest. So these are the knowledge graph Google built. So basically, heart disease is just one node, and this high blood pressure is associated with heart disease. So what does that mean? If you can understand high blood pressure, if you understand this data, the data will help you understand heart disease. It's like, again, going back to the financial crisis. If you understand the related events, you can help understand the financial crisis. So the Google also built the related events for each search. For any search you put in, heart disease, just one example. You can put anything. You can put FinTech. You can put some of you guys from the Full Hotel. You can put a city name there. You can put Xi'an there, Beijing, Shanghai. You can put everything there, and then they will give you the related knowledge, which is related to the search. And what does it relate for is, once you have this network, you can analyze the related data to understand the focal data, the focal sample. So like I said, you understand high blood pressure, it helps you understand heart disease. So this is so you can basically by doing that you can, so basically if you just study heart disease, you can never understand heart disease. But if you study high blood pressure, it may help you understand some knowledge about heart disease you can never obtain just being from studying merely heart disease. So this is the idea I'm keeping talking about the knowledge graph. So so another example here is geonames. Geonames is data set. So basically 25 million geonames, and then so people, they connect them. So basically we have different cities. You guys talk about different cities, hometown, Xi'an, hometown, Mongol, like different hometown, Shanghai, Beijing, Europe, a lot of stuff. So how these geographically they are connected? You build a relation between them. So you understand one city may help you understand another city if the relation between the two cities is well identified. So this is another knowledge graph. So basically, if I understand Beijing, if I want to understand Beijing, Beijing is, let's not talk about Beijing, let's talk about another city. If I want to talk about Wuhan, okay, Wuhan is my hometown. So if you want to understand Wuhan, maybe just by studying the Wuhan sample, you will never understand Wuhan. So you know the Wuhan when I was grew up, people call Wuhan Oriental Chicago. Have you guys heard of Oriental Chicago? So that means Wuhan is the Oriental Chicago in Asia. So what does that mean? That means if we understand Chicago, maybe it can help us to understand the future of Wuhan. I'm not saying that's true. I'm just saying when I was growing up, people saying Wuhan is Oriental Chicago. And this is just an example to tell you, if you really want to understand Wuhan, maybe you have to look at the pattern of the Chicago to understand Wuhan, the future, anything, the development and stuff. If the relationship is truly Oriental Chicago, that's one example the knowledge graph is doing. So what is WordNet? WordNet is also another knowledge graph using the language, using the words. So this is something you can also existing one. So what's a factor forge? Factor forge is like they have different factors and they contact the factors that as a network. So this is similar to what we're talking about. The only thing is the difference here is you see here is the city. Each city is a group. Here is each word is a group. Here is a fact is a group. So you connect the city together, connect the words together, connect facts together. So eBay also developed the knowledge graph for users and products. So basically, this is very similar to the Netflix I was talking with guys. If I'm a user of Netflix, you are a user of Netflix. What's our relationship, right? Are we share similar interests, or we are completely against with each other? So this is another example of eBay is doing that. So if eBay has done that, you can use that actually for your own research. We're trying to use the existing data. Think about it. Do you want to build this by yourself? Like whenever you search heart disease, you identify the related knowledge. You want to do that by yourself? You don't want, right? The wiki data, you don't want to do that. Like the relation between cities, you don't want to build it on yourself. No. So for us, what we want is you want to actually use the existing knowledge graph to extend your knowledge. This is something you can dig into. By using the existing knowledge graph, you can actually generate a new knowledge, like I said, like Wuhan. If you understand Chicago, you may help you understand Wuhan, which you can never learn from just using Wuhan's data. And that's new knowledge for Wuhan. That's what I'm saying, new knowledge. So that's why if you check my earlier videos, I already encourage people to use existing labeled sample, existing model. So for us, you want to stand on the shoulder of the giant. So in that you can move faster. So here the giant has been making so many knowledge graphs. You can use them, and each of them have very detailed menu. They give you details. What's the structure is due. It's like what do you do? It's like you buy the bike at home. The bike has a menu, like what's the bike is doing, and blah blah blah. So once you understand this concept, each of the data set has very detailed menu to let you guys know how exactly you can use them. That information is very detailed and well organized. But the first problem is you have to figure out what's this about and which data set you are going to use and what questions you are going to apply for. That's the difficult part. So I want you guys to keep your mind on that and on that part. And so what if there's no knowledge graph existing you can use? What if you have to build on your own? So there's several ways to build a knowledge graph on your own. So one is word embedding, another one is sentence embedding. We normally call it Google Bird, and also we have graph node embedding. So these are the two I explained in the earlier videos. I spent like tens of times explain what is Google Bird, what is word embedding. So I'm not going to repeat the techniques here. You guys can check it out. But I do want to see that you can see the relationship here. So if we use the king's vector plus the female vector, you will become queen's vector. So this is like typical knowledge graph, because if you add the king's vector plus female, the relationship between the two will be queen. So what the embedding can help you to build a knowledge graph on your own, So again, my point here is for knowledge graph, the first choice is to use the ones that already existed built by this Wikipedia, Google. You want to use the knowledge graph that has already been built by these companies, commercial companies, and you can use that. That's the first priority strategy. But in case there's nothing work out, there's nothing available for you, you can also build on your own. But I just suggest caution of using this way because it takes a lot of time, it takes a lot of effort, and you have a lot of techniques need to be figured out. So so if you want to build a knowledge graph on your own, it's not a very easy way. So you have to think about the cost, and you have to maybe wait a little bit for other people to build it. So for example, I give you guys an example of ImageNet. So Fei Li built ImageNet for a long time by label the image, and so all the common objects has been collected by the ImageNet. Same here. If you want to build a knowledge graph on your own, it will take a long time. But once you build it, you not just benefit yourself, you benefit everybody. It's like ImageNet. ImageNet is not just benefit Fei Li. She is benefit everyone. I'm using ImageNet. My colleagues use ImageNet. You will using ImageNet. So this is something. If you want to build on your own, the cost is very high, but it's not just about yourself. It's about the community. Even the examples I give to you, all the stuff they build is for the community, and it's a high cost. It's a cumulative work for you to do that. So this is about just quickly summary. We can use the knowledge graph to actually generate new knowledge. The agent don't even know by using related parties, related samples. And the key here is the pros and the cons here is you have to build the knowledge network on your own. And then the good news is this is like a simple example. The good news is sometimes you can use some commercial, some like existing ones, and use them to help you to generate new knowledge not available from traditional machine learning. And you can also build on your own high cost, but rewarding for the whole community. So so basically, so this is the knowledge graph. I want you guys to get the big picture of what is going on. And like I said, each of the graphs, if you search the each database, they have very detailed the menu for you to use them. But the question is not to figure out the techniques of this knowledge graph. The question is how you are going to use them in your research. That's the question. So for example, when I say the movie, that's an example, right? So how do I use, so let's say eBay. How do I use the eBay's network? Because the eBay can identify, let's say I'm a user of eBay. eBay can identify who are the similar users, who are the different users. They can use similar users buying preference for me. So that's a concrete application of using this. But how exactly you can use other database for your research questions? For what, like some of you want to predict stock returns, right? Some of you want to help managers. Some of you want to help investors. How exactly we use the knowledge graph to help us specific investor decisions? That's one way you have to think about it. You have to think about it, right? That's something you need to think about it. So so without a large training sample, like a financial crisis, that's a fantastic example, right? Financial crisis, because if you just study financial crisis, you will never understand the financial crisis because the limited sample size. But if you use related events, if you understand that, and then you also understand the relation between those events and the financial crisis, you can help us to generate new knowledge about financial crisis, which we can never learn from the past financial crisis events. So that's the applications you have to think about. So I thought about a financial crisis. Can you think about something else? Can you think about some niche that you have to use the knowledge graph to resolve. So another question is, people ask you, why use knowledge graph? Why not a neural network? Why not support vector machines? Why not other models? Why neural network? So you have to use the technology on the right question. You cannot just say knowledge graph is very fancy, it's cutting edge, so I use that. That's not the answer. The answer is knowledge graph can help me to answer this question, which other models will not, because knowledge graph has the function of blah, 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 blah. That's the answer you should give. So you have to use the technology, solve the research question. And that's justify why I use knowledge graph, not just because of the cutting edge. So just a little summary, What I encourage you guys to do is talk to a lot of industry people will help. So sometimes the industry people, how to get the research idea. One way to get research idea is reading papers. Another way to get research idea is talk to industry people, and you can actually see what industry needs, and you do research for them. This kind of paper are easy published and also well rewarded in the industry as well. So this is something I would say. A lot of you guys are doing fintech research. Some of you wondering how to get an idea of the fintech. So Professor, you are saying it's very difficult. It's very important to use the right technology to solve the research question. How do you get the research question? One way I suggest is to talk to a lot of industry people to see what they want. If you can help what they want, you can have a good paper. You have something which will impact the industry. And also read the news as well. Sometimes the news can help you to get the very practical reasons, reasoning as well. So these are the